Section 3.6 is problem solving using systems. Our one objective is going to be to apply systems of equation solution methods to word problems. In the first example, we're told that Jim has $17 more than Sam, and together they have $73. How much money does each of them have? So we're trying to find the amount of money that each person has. So let's say J is the amount of money that Jim has. And we'll say that S is the amount of money that Sam has. And if Jim has 17 more than Sam, we could start by saying Jim is 17 more than Sam. And together they have $73, so Jim and Sam, when added together, has $73. So again, let's reiterate. Jim has $17 more than Sam. Jim and Sam together have $73. So those are our two equations. How would we go about solving these? It doesn't really matter, but personally I would use substitution. I would take this expression right here that represents whatever Jim is and plug it in for Jim, giving us 17 plus Sam equals 73, giving us a final answer for the amount of money that Sam has is $28. If Sam has $28 and together they have 73, it means that Jim must have $45 as a result. How do we get that? We can plug in the 28 right here. For Sam, 28 plus 17 is 45. So if we made a verbal or written statement at the end, it would say Sam has $28 and Jim has $45. Example 2 says that a passenger jet took 3 hours to fly 1,800 miles in the direction of the jet stream. The return trip against the jet stream took 4 hours. What was the jet speed in still air and the wind speed of the jet stream? So in this problem, we've got an airplane. Okay, and it's flying. And let's say in the beginning, so it's flying to the right initially, and the wind, the jet stream, the wind is pushing to the right. So on the way there, the wind is helping, which makes sense because it says it only took 3 hours on the way there. But when this plane was flying on the way back, now it's flying into the wind. So it took 4 hours. So if the speed of the plane was, say, like 400 miles an hour, and the speed of the wind was like 50 miles an hour, we could say that really the plane is moving at like 450 miles an hour. We could add together their speeds because the wind is like a little push force, or it's helping. Okay, it's assistive. So in this problem, we have to remember that we have distance equals rate times time always. So in the first scenario, well, let's write our givens first. What was the jet's speed and what was the wind speed? So let's say that J is the jet speed, not jet stream, but the jet speed. And W, which is the jet stream, is the wind speed. Okay? So on the way there, it says, and remember our equation is distance, rate, and time. Here's our equation right here, D equals RT. On the way there, the distance is 1,800. And now the speed or the rate at which the plane is moving is the jet speed. But since it's moving with the wind, we're going to add that, and that's going to be our rate. Remember, the jet speed could be 400, the wind speed could be 50, so together it's like 450. And that took a total time of 3 hours. But on the way back, still 1,800 miles, same trip on the way back, it took 4 hours. And we know that now the wind pushed against the jet. So if the jet were 400, now we'd have to subtract the wind speed from it. So these are our systems of equations that we're going to get from this problem. And now we can just solve. The easy way to solve this is to divide by these coefficients on the right. Divide by these. So divide by 3 on both sides, divide by 4 on both sides. That's going to result in 600 equals J plus W, and 450 equals J minus W. The reason this is convenient is because now you'll notice that the W's just cancel if you add straight down. And what we get is 1050 equals 2J. Again, add this straight down, and that's the result that we're going to get over here. Which in essence means that the jet speed, the plane itself, is 525, and this is in miles per hour. Our time was in hours, and our distance was in miles. Well, if the jet is 525 miles per hour, and we go back and look at this equation right here, we can remember that this must have to be 75. 525 plus 75 equals 600. So the wind speed in this problem is 75 miles per hour. So as a verbal statement, we could say that the jet speed is 525 miles per hour, and the wind speed, which is the jet stream, is 75 miles per hour. Example 3 says an exam worth 145 points contains 50 questions. Some of the questions are worth 2 and some are worth 5 points. How many 2-pointers are there and how many 5-pointers are there? So our let statement is the number of 2-pointers and the number of 5-pointers. So X is the number of 2-point questions and Y is the number of 5-point questions. Now, together there are 50 questions. Boom. There's one statement right away. Again, together there are 50 questions. Together means X plus Y. But now we have to think about the point worth. There's 145 points in the test. Let's say there were 10 2-point questions. If there were 10 2-point questions, you would say, okay, 10 times 2, because they're 2 points each, means you can get a total of 20 points from there. And the exam is worth 145 points. So the whole exam is worth 145 points. And if we knew that there were 10 2-point questions, that means that it would do 10 times 2 to give us 20 points. So really, we could say that 2 points per question times the amount of questions there are worth 2 points each, plus 5 points per question times the number of questions there are at 5 points each. So again, let's think about a scenario. If there were 10 2-pointers, you would put a 10 here, and you would say that there are 20 points of the test is made up of 2-point questions. But here, let's say there were like 30 5-point questions, you would put a 30 right here. Well, clearly that's not possible because 30 times 5 is 150. But the idea is that if there were a certain amount of 5-point questions, you would take that amount and multiply it by 5 to get the number of points that it makes up. So we could technically here use our dimensions, and let's see what I'm talking about. If you had trouble with that last statement there, let's make sense of it. So I'm going to break down this equation right here. The units here are what's important. So this is our system. We can leave that alone, but just to break it down. The units of 2 are points per question. And the units of X are questions. There are X questions. Okay, X questions. Then we have 5 points per question times Y questions. And this equals 145, and take a look, 145 units are points. What you'll notice is that questions cancel everywhere. And you notice that if you multiply 2 times X, the units end up being points. If you multiply 5 times Y, the units end up being points. And the units of 145 are indeed points. So this method can be checked or can be derived from looking at your dimensions. But let's go back and take a look now. Our system up here is simple to solve if we multiply this equation by -2. So it would put a -2 here and the +2 here. So let's take equation 1 and multiply it by -2 and add that to equation 2. So equation 1 times -2, I should write it this way actually. -2 times equation 1 plus equation 2. Let's perform that operation. So if we multiply equation 1 by -2, what we're going to end up getting is the following. -2x minus 2y equals -100. And then to that we're going to add equation 2. Equation 2 is 2x plus 5y equals 145. And we'll notice now that our x's have opposite coefficients. We can add straight down, giving us 3y equals 45, or simply y equals 15. Well, if y equals 15, that means that there are 15 5-point questions. Well, there's a total of 50 questions, which means that there are 35 2-point questions left. Okay, so when y equals 15, really x equals 35. And we could get that by substituting back into either of those equations. Example 4 says, together John, Bobby, Kristen have $70. Together John and Bobby have $39, while Kristen has 4 more than Bobby. How much does each of them have? So we're looking for the amount of money of each person, so J, B, and K. J being John's money, B being Bobby's money, and K being Kristen's money. With those three let statements and our problem, we can go ahead and write our equations. I'm going to read and write at the same time. So reading the first sentence, together John, Bobby, and Kristen have $70. That tells me the following. Next, we're told that together John and Bobby have $39. And finally, Kristen has $4 more than Bobby. So we have three equations and three variables. At first, it may be tempting to say, all right, well, let's put everything in order, get all of our variables lined up, and go ahead and use a matrix or elimination method. But actually, it's easier in this problem to use substitution. Here's why. J plus B is 39. Well, this is J plus B. So you can replace this quantity here with 39, which really gives us 39 plus K equals 70, and therefore Kristen has a total of $31. Well, if Kristen has $31, we can take that and plug it in here, realizing that this must be 27, for 27 plus 4 to be 31, so Bobby has $27. And then finally, if Bobby has $27, we can take that quantity and plug it in here, and if Bobby and John together have 39, and Bobby already has 27, that leaves John with $12. So our final answer would be that Kristen has $31, Bobby has $27, and John has $12. Again, you could have solved this by ordering your equations and using a matrix. If you wanted to see that, I'll show you the setup real quick. Here's what it would look like reordering these equations. The first one's good. J plus B plus K equals 70. Second one's all right, but we write J plus B, and let's remember 0 here, okay, equals 39. And the third equation for this one, we'd have to move the B over. We'd have 0 for J, because it's not mentioned in the third equation. Moving this B over makes it a negative B in the front. So minus B plus K equals 4. So if you want to use this and use a matrix, your matrix would be 1, 1, 1, 70, 1, 1, 0, 39, 0, negative 1, 1, 4. Okay, again, noticing that this happens to be a 3 by 4 matrix because we have 3 rows and 1, 2, 3, 4 columns. You could use RREF on the matrix to reduce it and get ones in your pivots to see your final answers, and these are the quantities that you would indeed get. Our final example says, Michael, James, and Joey go to Shake Shack for some burgers, shakes, and fries, or burgers, fries, and shakes. On their first visit, they purchase 5 burgers, 3 fries, and 3 shakes for $35. A week later, on their second visit, they get 4 burgers, 5 fries, and 4 shakes for $39. And a few days later, they get lunch again from Shake Shack, and they order 6 burgers, 4 orders of fries, 3 shakes, and it comes to $42. What does each item cost? So we should start with burger as a B as a burger cost, F as an order of fries cost, 1 order of fries, and S as a shake cost. Those are the 3 unknown variables. Well, on the first visit, they get 5 burgers, 3 orders of fries, 3 shakes for a total of $35. On the second visit, they get 4 burgers, 5 fries, and 4 shakes for a total of $39. And on the third visit, they get 6 burgers, 4 fries, 3 shakes for a total of $42. Notice that there's no negative coefficients or numbers anywhere because these are amounts of shakes, burgers, or fries, and amounts of dollars, which are all positive amounts. Now, for a problem like this, I would definitely recommend going right to a matrix once you set it up, and that's fine. And our matrix would look like the following. Okay, from our 3 scenarios, if we perform our REF, our calculator operation, on this matrix, as a result, we end up getting the following. And again, we'll have ones in the pivots we know already. We'll end up getting 4, 3, and 2. And if you remember, this represented burgers, this was fries, and this was shakes in the columns. So one burger is $4, one order of fries is $3, and one shake is $2. Clearly, these prices don't reflect Shake Shack that we know. When I had this question in mind, I was actually thinking of Checkers restaurant, which is less familiar to most people, but those are the approximate prices at Checkers. Your homework for this section is from 3.6 and a review problem from 2.3.